Welcome back, everybody, and we're going to continue on with this video here. We want to learn how to find the true distance between a plane surface and a point in space. And if you look at this first step here, and given a point, a true distance here between the plane and a point. So this is the point, and then here's the triangle ABC at the front view, and the same triangle here at the right side view, the same point here at the right side view. And now you can have to draw a parallel to this to the fold line, this parallel here, and then you can project this to your front view. And once you project it to your front view, draw this line to from F to CZ is going to be the true length of the line. What is the true length? And again, one is a parallel. You draw from a parallel plane, that would be a true length of the shape. So now you're gonna, from this triangle here, you're gonna project them all the way to get your auxiliary view, and everything draw perpendicular to the fold line. And this is your new point here. You're gonna transfer this distance here from where you always skip a view to get the distance from here. So your A point, this distance here, equal to this distance here. This distance here to this point is this distance here. And now you do the same thing, measure this distance to get this distance, and you get the H view. This is your H view, and this point here now, from here to here is your point. And to get this true distance, you would just measure this H view from the H view to the point, will give you the true distance. And finding the angles, construct a true length line of the intersection between the surface, project or point from each plane to this line, project the end view of the intersection, project the points of both planes into the secondary auxiliary view, and measure the true angles. To accomplish this, and we're going to follow this few step here. So given this this triangle here, the top view, the front view, and the right side view. And next thing you want to do is to draw the auxiliary view from the top view. To draw the auxiliary view, you're going to draw a line that is parallel to, draw a line parallel to point AB, draw a line parallel to point AB, and then project all this line perpendicular to the fold line. And where do you get the distance? To get this distance, you always skip a view, go measure distance from here, transfer over here. So the point C, as you can see, the point C, transfer over here will give you the C, but it's auxiliary on at the auxiliary view. Same thing to D, this distance transfer here, this distance over here, and then this distance over here, and then connect all these dots to get the true length of the fold line AB. So the true length here is the true length here, because always when you have when you draw a line that is parallel to this fold line, and this line always be the true length. So once you have the true length, now from this view, you're going to draw the secondary auxiliary view, where you're going to get the H view, and then get the true angles. So when you get to when you draw this line here, this line is the perpendicular to this line here, and this DB parallel to this line here, and then you're going to draw perpendicular to it. And once you draw perpendicular to it, you're going to get the true angles. What angle between what angle? So they want to get the true angles between here. You have this two surface here, one surface and two surface. They want to know what is this angle. The angle between CT, AT, and DT. Now you got CB. Is another word, you need to know the angle CAD. CAD will give you the true angles. If you use a protractor and measure the angles, it's going to give you the true angles of these two planes. And now the next thing here is how to determine the visibility of line. And to determine the visibility of line, and you don't know where and at what location is the lines going to be overlapping to each other, or how do you find out which one go first? To determine that, first thing, given this two crossover at X, crossover at Y at the front view, and now if you, from this intersection point, if you project them, if you intersect with CD line first, that means this is going to be the overlapping. So if you continue on doing the same way, you're going to go from the intersection point, project them here, and if you hit this line first, that means your overlapping line is AB. So let's go back to this one. So from this intersection point, project here, now you intersect at CD. So when you intersect CD, that means the CD is gonna go over the AB. So let me repeat that. So this CD line and the CD line here, you see this line here? This line here is solid. That means this one here is on top of this AB. So this CD is on top of the AB. So I hope it's very clear. If not clear, let me know. So continue on. So from here now, I already determined which one is on top. Which one is on top first. Now that from here I know the CD is on top, so do the same thing, project them back up, and now you're gonna hit the AB first, so you know AB is on top. So when you project this up, you hit this first, so you know AB is on top of CD. So you would draw the line, solid line, and then the bottom, the CD at the bottom, so you would draw the dash line and then dash line to show the CD at the bottom. So this is how you determine the visibility of the line. I'm gonna end this video here, and then we're gonna go to next video to talk more about the piercing point by either inspection or construction.